Hello, here is Jaroslaw Stakun speaking. I'm Principal Solution Architect at Red Hat. In this presentation, I would like to give you an introduction to Red Hat integration portfolio and tell you a little bit how you can integrate your existing legacy applications with the new cloud-native applications. So today I will focus on four major solutions. So we'll start with the API lifecycle management solutions. Then I will talk about the event-driven architecture and messaging solutions. Then I will go to the enterprise integration topics. And last but not least, I will talk about the data integration. So the Red Hat integration portfolio is quite comprehensive. It spans across those four major technology solutions I mentioned, and it provides a set of different products or components that address both the enterprise integration, the typical messaging solutions, and event-driven streaming solutions, tools for implementing the APIs, governance processes, the platform for API management, and also the solution for data integration. So the first topic here is the API lifecycle management solutions. So as you can see, the API lifecycle is quite comprehensive. So there are kind of two complementary lifecycle. So the first one here is the lifecycle of the implementation and deployment of the API. So this typically starts from some design, testing, mocking, implementing using your favorite or selected technology, and then deploying to the execution environment, and also managing the life cycle of deployed API endpoint. On the other hand, there is a second life cycle here, which is related to the way how the API is consumed. So first, the client needs to discover existing APIs, develop some integration, and start consuming the API, and then we can monitor the API consumption and monetize on top of it. The second group of solutions are the event-driven architecture tools and the classical legacy messaging platforms. So the event-driven architecture is a way how we can design applications or services which will consume real-time data informations that will be sent to them in the form of events. So this event-driven architecture approach is very useful in a number of ways. So first of all, you can use event-driven architecture to implement the asynchronous communication between your microservices applications, so that some microservices will send events and the other will consume, and you can use the centralized event streaming platform as a backbone of this architecture. The second use case could be the solution where you want to stream data from one system to another. So this could be So the source of the events could be either relational databases, or this could be some log systems which generate logs, and those events can be sent to the dedicated event-driven middleware and could be consumed by other consumers of those events. So if we look on this event-driven and messaging portfolio, we have number of components here. So first we have our AMQ broker, which is a traditional message broker that you can leverage to send messages and to create the queues and topics and to integrate applications using this message-driven middleware. The second one is AMQ interconnect, which is basically kind of messages routing layer. So the interconnect do not persist data, unlike the message broker, but you have possibility to build distributed kind of mesh of this AMQ interconnect servers, and you can very easily send or propagate messages from one brokers to another. And the first solution is AMQ streams here. So the AMQ streams is a streaming event streaming solution based on the Apache Kafka, which you can use to stream events and to consume those events in an asynchronous manner. Also, there is an AMQ online solution which provides you capability of kind of managed service for AMQ brokers and AMQ interconnect. So those solutions can be deployed either on OpenShift or with exception for AMQ online on the operating system in non-containerized environment. To kind of better understand what are the purposes of those three solutions, we need to understand what type of events can be sent and consumed to those systems. So here you can see we have three types of events. So the first type is kind of notification style events, where we receive some information about some operation that has been executed on the target system. Then we have comment events, and those events are kind of requests in a form of remote procedure calls, which contain kind of information or instructions which gives some task to do to the recipient of this command. And the third one is query. So the queries are similar to the commands, but the difference is that they don't really they should not create any task on the target system. They should rather they rather accept to receive some information as a response. So for those three types of events, we can choose between the four solutions I was talking about. So here you can see that AMQ broker, for example, the traditional messaging solution is best fit for durable events. So because it has a capability to persist the messages. It can be also used to non-persistent, so volatile events. It can be used to receive comments or queries, but it is not a good fit for replayable events. So these replayable events are great fit for AMQ streams because AMQ streams has this capability built in, so it allows you to repeat the events from some point of time. On the other hand, the interconnect, because it does not have a persistent storage for messages, it's really great for kind of in-flight messaging, so sending comments, queries, or non-persistent events, and is not a good fit for durable and repeatable events. So now let's move on to the third category, so the enterprise integration. So the enterprise application integration requirements are changing over time. So we can say that in kind of legacy world, we had mostly the SOA-based integration, where there was a central enterprise service bus integration layer, which was kind of proxy between the services APIs exposed by different SOA services. When we move forward towards the cloud-native integration, where we might have an application in a distributed architecture where there will be multiple services running either on-premise or somewhere remotely in the cloud or in some remote data centers, we will need more kind of point-to-point dedicated integration and direct integration between the services. So to fulfill those requirements, both the kind of centralized integration as well as the more cloud-native integration requirements, we have been contributing for many years into the Apache Camel project, which where the community is developing an integration platform that could fit to both of those architectures. So in Apache Camel consists of multiple enterprise integration patterns, which are kind of ready to use building blocks for creating different integration solutions and to implement different integration scenarios. It has over 300 different integration components, so kind of connectors to third-party systems that you can leverage to easily integrate with those systems. It supports different runtimes, so depending on your architecture, whether you want to build centralized integration or more lightweight integration, you can choose between different runtimes. And last but not least, of course, it supports different data formats and provides the transformation functionality that allows you easily to transform between different data formats. But this integration requirements are moving even further. So now kind of new style of building the integration logic is to leverage a serverless functionalities. So in essence, the serverless integration works in a way that we define some integration logic, but and when we deploy this logic into the integration server, but this logic is only deployed and executed when there will be some events sent to that to the service. So we are relying here on the scaling capabilities of the serverless platform, which can scale dynamically our services based on the real traffic generated to those services. And also Apache Camel is supporting this new integration paradigm with the new subproject called Camel K. So the way CamelK works is quite straightforward. So first you need to define the integration logic using the Apache Camel DSL, just like you would do in a traditional integration application. Then you deploy this logic to the server using either the Camel command line or other ways, and then you run it in a serverless fashion on top of the integration platform. Of course, in case of the Red Hat environment, we leverage here OpenShift and the containers as a runtime for our serverless integration platform built using the CamelK. And moving forward, the last integration related solution are the data integration solutions. So here basically we do offer currently one solution which is a change data capture. So the change data capture is also a kind of similar solution to event-driven architecture. So idea here is that we consume events created by the databases when the new transactions are executed. So basically every transaction that results in the change of the data on the source database is being registered and sent to the dedicated event-driven messaging or streaming component. In our case, of course, we leverage the Apache Kafka, and these events can be then consumed by the target systems. So there are multiple use cases for that solution. So first of all, this is the way how we can replicate the data between the systems. So whenever there is a transaction committed on the target system, the event is sent to the Kafka server, and then it can be consumed by other systems which can take some action based on the data. Then, of course, in a new cloud-native microservice-based architecture, this solution could be used to synchronize the data between the data stores of different microservices without a need to have central database, which could be kind of bottleneck in this architecture. And there are of course some other use cases where you can also use this platform for some auditing, some in-memory data caching, and other use cases. So the solution here is based on the Debezium project. So the way it works, so you have connectors that are listening to the events that are sent to the database's transaction log. So we support different database systems here, and then based on those logs, the platform creates events that contains transactional data that is stored in the log, and this data is sent as an event to Apache Kafka, and then there might be some consumer connected to those topics who will receive those events and will take actions accordingly. Although the project itself is quite new, so it has been so the version 1 was released just in December last year. It is already quite popular and used by many customers in production environments. So this concludes my presentation. So I have discussed here 4 types of solutions that we provide as part of our Red Hat integration portfolio. So the API lifecycle management solutions, the event-driven architecture and messaging solutions, the solutions for different enterprise integration scenarios, and last but not least, the change data capture solution for the data integration. Thank you very much for your attention. I hope you enjoyed the presentation, and of course I encourage you to try those tools in your environment. Thanks and bye.